If your bacteria was a gram-negative bacteria, and you would know that by looking at your descriptive chart under morphological characteristics, under gram stain and cell shape. So your gram stain would have been gram-negative. Your cell shape would have been likely a rod. So you follow this thing, it's called a separation outline. So you just look at your descriptive chart and you find the results here. So you probably have a rod, you go to rod, you have to know whether you have an aerobic or facultative anaerobic bacteria. And I gave you the directions on that in one of the previous videos. And then once you get there, say you had an aerobic or obligate aerobe bacteria, you would end up in group, this is group 8. And there's 2 genuses in that group, Pseudomonas and Alcalogens. Now, if you look at the unknown species list, you'll notice that Alcalogens doesn't exist. That means that you are just looking and comparing your unknown test results with Pseudomonas, which is fine. Let's say you have a facultative anaerobe. Then you could end up either having a motile or a non-motile bacteria. If your bacteria is non-motile, the group that you belong to is group 10 and you're in the Klebsiella group. If you have a motile bacteria, you end up having a very large group. You end up in group 9. Group 9 is very big, and for that reason, I would have given you, and you'll have available to you, a second separation outline to break up group 9. So again, we've got non-motile, probably you were citrate positive, you end up in Klebsiella, that's it. But if you were motile, now you have these other test results that you will be comparing with your unknown. And you're going to use your descriptive chart, again, to look at these test results, and that's where you're going to get them from. And that'll lead you to kind of breaking down this bigger group a little bit smaller. And then the idea is to make sure that whatever group you end up in is in that list that I gave you that is called Microbiology 223 Possible Unknown Species List in the modules for the unknown report. So if you did, then you're cool. You probably have the information to know what your unknown is. If you didn't, you might have to email me and I'll have to try to help you figure out what went wrong. Sometimes things go wrong because test results aren't always what they should be. When you get a positive test result, that means that 90 or plus species of that same species is going to give you the same test result. But that means there's 10% that you could get a negative. Like if you were expecting a positive, you could maybe get a false negative sometimes. So nothing in nature is perfect. And that's how we sometimes end up in groups that don't exist. I don't think that's going to happen to anybody this time because I'm giving you the test results that usually screw up, but it could. So if you end up in a group that doesn't exist, email me, let me know, and I can kind of help get you through that. But anyway, once you get this done, let's say you were group 9, you're motile, you're citrate positive, you're lactose positive, you're methyl red positive, so you end up in Citrobacter. Then you look at the list and you see that there's one Citrobacter species, Citrobacter diversus. It's possible that that's your species, but I want you to do a little bit more investigating. So those of you that ended up in group 9, and actually that have any gram-negative bacteria have just a little bit more work to do. But specifically, those of you that end up in group 9 do. Okay, so you end up in group 9. You have this handout that I am giving you. I filled out all of the test results for all of the bacteria in group 9. Notice here, there are some Ds. Ds mean that there is an 11, what is it here? It's an 11 to 89% or more of strains are positive if you get a D. Those are really weird, funky ratio results. So where there is a D test result, we're just going to cross it out. And when we count how many bacteria we can compare to our unknown, we're not going to count those Ds. So this is a chart that usually I give to all of you that ended up in group 9, and you end up having to fill these 2 lines on your own. You have to go to Bergey's manual, which is the manual that you have to look all this stuff up from and get these test results and then compare all of these tests with your unknown. This is where you would write your unknown test results right here. But because we couldn't use Bergey's, given that we are online, I gave you these test results. So ideally, you're going to go to your descriptive chart and you're going to write all of your test results here. And then you're going to compare the test results that you can match here with the ones here, okay? You're also going to be getting I have written here for reference only. I would have given this to every single one of you so you could kind of understand how to do what's called numerical taxonomy method. So only those of you that end up in group 9 will actually have to fill this handout out, and you'll use this for reference just in case. But notice that here I wrote all of my test results there. And then in this case, I've got test results for 1, 2, 3, 4, 5 bacteria that I'm comparing my unknown to, because this is for reference. This would be the one that you're actually doing your work on. This is just to show you how to do it. Anyway, so I write all my test results there. I've got some things that are crossed out. Those are those D's that I told you are funky, wonky results that we're not going to count against our bacteria. And then I circled the test results that don't match. So for instance, see here, this test result is circled. I have a positive test result and this one's giving me a negative, so I circle it because it doesn't match. And I circle it because I've already crossed out these D's, meaning I'm not even going to count those. But these are going to count with relation to unlike unknown. And so you need another way to figure out what you're doing there. So anyway, so like tryptophan doesn't match. Methyl red in this case doesn't match, so it's circled. Simmons citrate doesn't match, so it's circled. Urea doesn't match. So you can see the situation here. Let's look at Citrobacter diversus specifically. I circled Vaux Proscour because it doesn't match. Simmons citrate because it doesn't match. I crossed out that D that's right there. I circled gelatin because it doesn't match. That lactose is crossed out because it's a D. And then the mannitol is circled because it doesn't match. So this 9 out of 13 ratio is how many test results are similar to my unknown compared to how many tests I can compare to my unknown. So we're going to go down the line, all the test results that we can compare to our unknown, and we're not going to count the ones that are crossed out, the D's. So here we go. And color is a matching countable thing. So we've got 1, 2, right now we're going to get this bottom number, this 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, not going to count that D, 10, 11, 12, not going to count that D, 13. So that's how I get 13 tests. Those are 13 tests that are similar to my unknown. I'm sorry, those are 13 tests that I can compare my unknown to. And then I get this 9 out of 3 because there's 9 test results that match my unknown. So here's how we're going to get those. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how we get the 9 out of 13. So on the flip side, unlike unknown is 4 out of 13. We're going to count the ones that are circled. 1, 2, 3, 4. So that's how we get 4 out of 13. So the idea is when you're done with all of this, the bacteria that has the best test results out of this similar to unknown are likely to be your bacteria. So you may end up with some that are very, very similar. I don't think that any of you will end up with 2 bacteria that are exactly the same number. I think you won't. But if you end up with 1 or 2 that are very similar, you want to go with the one that's got the best ratio, obviously. So if you have a ratio of 13 out of 15, that is probably likely to be your bacteria. So that would say Proteus vulgaris is likely to be my unknown. But if you look at this, look at these ratios. 11 out of 13 and 13 out of 15 are basically the same ratio. There's 2 unlike in both of these scenarios. But I would still go for Proteus vulgaris because Proteus vulgaris has more test results that I can compare my unknown to. So even though this number, 2 out of 13 and 2 out of 15, kind of seem to be the same because that's the unlike unknown, 15 tests is better to compare with than 13 tests. So I would say that Proteus vulgaris is my bacteria. So if we're working backwards here, again, you may end up, it's Citrobacter here, but you may not actually have Citrobacter. This is only giving you 1, 2, 3, 4 test results. This is giving you all of the test results. And I think there's 15 or 16, actually maybe 17 here. So you need to finish, I have finished this out for you. You need to do the numerical taxonomy. You need to write your unknown test results here. And you need to see how many test results you can compare to your unknown at the bottom number here. How many test results match your unknown at the top number there. And then unlike unknown underneath that, just like in my reference sheet. And then when you're done doing all of those numerical taxonomy counts, the ratios, one of them will be the best one, and that's the one that is your unknown. Does that make sense to everybody? I hope it does, because it shouldn't be that hard. You're not looking anything up. You're just going from the separation outlines to this. And I've given you this one. This should be the last page in that module tab, just for reference to show you how to do that math. So again, this 9 out of 13 is 9 matching test results to the 13 tests we can compare our unknown to. These D's that are crossed out are going to not be tests that we even count. They were test results that were given in that Berge's manual, but that D is such a funky, weird result that we can't really count it to match anything. So if we want to count how many test results we can compare with our unknown here, we get 15, because if you look, there's no D's. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 tests. That's why there's a 15 down there. And then we circled the ones that don't match our unknown. And when we count those, there's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see how that's how we get the 9 out of 15. And then 6 out of 15 are how many tests are unlike the unknown, which are the ones we circled. So they stand out to us. 1, 2, 3, 4, 5, 6. Okay. So again, you do all of that, then you figure out which is your unknown. And then once you have that down, you can write your unknown number down. I'm sorry, your unknown name down on your descriptive chart. And then you'll look up diseases that your bacteria causes and write out a little paragraph about that.